In this lecture, I'm going to look at I guess we're going to look at a different way of thinking about what to do when the group, when group number 4 is not in the back. So getting right into it, what I mean by that is, if you remember, one of the important rules for determining or assigning RNS on a molecule is to ensure that the fourth priority element is in the back. Okay, so let's look at an example. And I guess at first, let's not make it too complicated. Okay, so we have 1 for bromine, 2 for ethyl, and 3 for methyl. We've done this assignment before, so I'm going to roll through rather quickly. Now, for every dash, there's a wedge. So for every dash, there's a wedge. Let's put the wedge out there, which in this case is just the implicit hydrogen that we don't have to draw. So hydrogen gets group number 4. Now, we can't just connect 1 to 2 to 3 in this case, because we'll get the answer wrong. Okay, so we have to instead, and let me just emphasize this because it'll be my main point. If number 4 is not in the back, then we're going to get the answer wrong. And we know that because we didn't roll it around and put it in back. The answer is wrong. So what that means is, even though I want to write R, the answer is wrong. It's clearly S. So honestly, if we just know when we're wrong, we know what the right answer is. Okay, anyway, let's go ahead and roll the molecule around in our head. So I'm just going to spin this molecule 180 degrees. Now I know that's not a trivial thing to do, but think about just picking it up by one point and just swooping it over to the other side, just spinning it around. If we do that, then the molecule is going to look like this. Okay. Remember that the H and the B are directly on top of each other. So how I decide to skew them so that I can see both groups is totally up to me, but in reality, they're right on top of each other. So bromine is 1, ethyl group is 2, methyl group is 3, then hydrogen is 4. Now hydrogen's in back. So with hydrogen in back, we can just simply go from 1 to 2 to 3. And thank goodness we did that, because now we know the answer is S. Whereas before we knew we were wrong, which allowed us to realize that the answer was S. That's kind of helpful, right? If you look at the molecule and you're like, oh shoot, number 4 is not in back. What am I going to do? Well, I'm going to get the wrong answer. But if Willoughby wants me to know, or wants me to figure out whether it's RS, I can tell him the correct answer to that. I can tell him that it's S in this case. And I've shown a lot of my work. I prioritize the groups, which is more important to Willoughby at this stage than rolling the molecule around correctly. That's really helpful. That's good to know. So what you can do is, so this is kind of a tip from me, is to recognize when you know you're wrong. And by that, I mean you don't want to misprioritize. You want to get the 1, 2, 3, 4 correctly, but recognize when you know that you're wrong, your answer is wrong because number 4 is not in the back. To get the right answer. Now, there's some caveats here that we have to be mindful of. And so there's a better approach. What we really need to do is don't just stop here. Don't stop the video. Keep watching, because there's an issue here that we have to recognize. We have to, let me provide a better tip. What you want to do is swap number 4 with whatever is in back and connect 1 to 2 to 3, which gives you R/S, and then take the opposite. And that gives you your answer. So here's my tip. if number 4 is not in back, I think this rule, and my previous students have said, they agree once they get it and they make sure. What's nice about this approach is you don't run the risk of having mistakes happen because you misrotated the molecule. You rotated the molecule over and you forgot to flip a wedge or a dash around. You forgot to exchange the left side for the right side. All these things that can happen, we can avoid by remembering this sort of simple rule. So what I mean by that is we're going to, let's take our original example. Now, it turns out you don't need to worry so much about this if number 1 is the thing in back. Okay, so we went 1 to 4 to 2 to 3. Now, what I'm going to do is I'm going to cross out the 1 and the 4 and swap them. So I've swapped the priority on the hydrogen and the bromine. And then I'm going to connect from 1 to 2 to 3. Now, I got the exact same arrow that I did up above, but it was only because number 1 was in the back. It was how the molecule was oriented. But by swapping the groups and then going from starting at 1 in this case, and then going around, we'll still get the correct answer as long as we know that we're wrong. So what that tells me is that I have an R answer, but I need to take the opposite of it. So I'm going to multiply it by -1 to get S. Okay, so this times -1, that is the mathematical equivalent of taking the opposite. That is the mathematical definition of the opposite of 2 is -2. So anytime you multiply a number by -1, you get its opposite. The opposite of -5 is 5. So -5 times -1 is 5, that sort of thing. Okay, so I just write that in here. I write -1 to tell me to take the opposite. But the important thing that I did differently was I wrote in red, just bring it up here. I wrote in red the switching to make sure that I was keeping track of what happened to number 4 and the thing that wasn't back. Okay, that's important because that will, if you do that every time, you won't accidentally get tripped up. There are situations where, let's make this not too small. Let's take an example where we've got some stereocenter. We've got a wedge and we've got a dash. Whoop, don't want to put hydrogen in the back. Let's put CH3 in the back. And now hydrogen in the front, Br ethyl. Now this is a case where I don't really want to rotate the molecule, or I mean, if I can correctly do it, wonderful. I should, as an organic chemistry professor, I should encourage this. But you get to the point where you're like 1, 3, 2, 4. We've prioritized these groups several times. When you get to this point, it's hard to see that what we want to do is a 90-degree clockwise rotation. Okay, that's a difficult thing to see. So 90 degrees clockwise. Let's go ahead and we will do it to say that we did it. Now, if I do that, I've got this situation, and I've got 4, 1, 3, 2. Okay. So now now that number 4 is in the back, I can go 1 to 2 to 3. Is that? Okay, 1 to 2 to 3, which is clockwise. So that's S. Okay. That was kind of a lot of work, right? I mean, if you look at this, a 90-degree clockwise rotation is something that, like, you do with a lot of practice. It would be nice if we had something systematic. Well, there is. We're going to swap number 4 for what's in back. Let's swap number 4 for what is in back. And that's number 3. And then we have number 4 here. Okay, so now I'm going to connect from 1 to 2 to 3. And that tells me I've got R, right? Well, no, R is wrong. Because number 4 is not truly in the back. I didn't rotate the molecule properly. Shoot, what am I going to do? Well, if I know I'm wrong, then I know what the right answer is. I just take R times -1, the same as taking the opposite. The opposite of R is S, and that's the correct answer. So we prioritized correctly. We recognized that number 4 was not in the back, and we flipped it with something that was in the back. In this case, it was number 3. If I had just ignored it, recognize what would happen if I just ignored it. I haven't tested it on this example yet, but if we didn't do that switch, if we just ignored it and said, hey, you know what? We might get the same answer here. So if we're at 2 to 1 to 3, remember that, see, the trouble is 3 and 1 are directly on top of each other. So if I drew it this way and I said R times -1 equals S, that's not really that good, because I could have just as easily drawn it this way, in which case you might be inclined to make your arrow this way and take the opposite, and it's R. To avoid the ambiguity, let's do the full switch, right? Just switch them for what is in back. Switch number 4 with what is in back, then go from that sort of revised priority and take the opposite. You won't be misled in that case. Okay, so it's a nice rule. When you get the nuances of it, it works a little bit better than having to rotate the molecule around, especially when the molecule gets more complicated. I mean, just an ethyl, a methyl, and a bromine isn't too bad. You can recognize the priorities right away. But what about something like this? What about something like this? Okay, so our stereocenter is at this position, at the carbon with a star. What we need to do is compare the elements directly attached to that carbon. So we have oxygen, nitrogen, carbon, and carbon. Okay, so oxygen is number 1. Number 2 is nitrogen. And that's just me remembering that it goes C, N to O. So now I have a tie for 3rd and 4th between the 2 carbon elements. I'm going to label one a triangle in this case and another one a dot. So C triangle has attached to it an O, a second O because there's a double bond to the O, and then a C. Whereas C dot has attached to it a carbon, a hydrogen, and a hydrogen. Okay, so we can tell right away the higher priority goes to triangle. So we have 1, we have 2, we have 3, and we have 4. Okay. So to rotate this molecule around, we need to do a 90-degree counterclockwise rotation towards us, and then a 60-degree rotation downwards, or a 90-degree rotation back. The 90-degree rotation back would be simpler, but then it's harder to draw the molecule. Because of the ring, this is a tough molecule to draw in certain rotational schemes. This is a really hard one to get so that number 4 is in the back. How are we going to figure out R and S? Well, let's do the old switch trick. Okay, so what we want to do is we want to flip number 4 with the thing that is in back. It's always the thing that's in back. I'm not looking for 1, 2, or 3. I'm just looking for whichever one is in back. So in this case, it's 2. So I'm going to write a 2 next to carbon dot and a 4 next to nitrogen, in which case I would get 1 to 2 to 3. Oh, it looks like the answers are. Well, no, R is wrong. We did the switch, so we're going to get the wrong answer. R times -1 is equal to S. So the molecules, as they get bigger and more complicated, they're more and more difficult to rotate around in 3 dimensions. Now, we don't want that to stop us. I mean, I could do a 180-degree rotation, but then I would still have a different group in back. We don't want that to stop us. We don't want the complexity of the molecule to make it so we can't analyze the molecule for R and S in particular. This allows us to handle more complicated molecules. If we can prioritize it now, we can assign it R and S without number 4 being in the back, without that rule getting in the way. And so this becomes a really powerful technique for assigning R and S to many complicated molecules. Because again, our job as organic chemists is to be able to analyze and not be intimidated by the most complicated of molecules. So this was kind of an interesting lecture. You won't see this sort of technique taught too often. Now, it's been about 8 years of me doing this, where, you know, the first few years I maybe had some aspects of the rules weren't refined and people were able to come up with examples where it broke. And then I sort of worked on it. And I was like, okay, if you do it this way, if you flip whatever is in back and then go from there, you can get the right answer without having to rotate the molecule around. You just know then that you have the wrong answer. That puts the emphasis, I about said the priority, puts the priority on the prioritization, which is the important aspect, the prioritization. And then from there, you know, remembering clockwise and counterclockwise. So hopefully this tip will help you. If you have questions about it, let me know. Practice it before moving on to the exam questions.